Okay, this first video is solving radical equations, and this is part 1 of 2. So when we solve radical equations, the goal is to get rid of the radical, and if we can get the radical by itself on one side of the equation, we can get rid of the radical by squaring both sides. So on the left, when I square the radical, I'm just left with what's underneath, so I get 3x minus 5 equals 6. So then to solve, I'm going to add 5 to both sides. Oops. Doesn't equal 6. When you square 6, you get 36. I'm sorry about that. So then I get 3x equals 36 plus 5 is 41. So now to solve, I'm going to divide both sides by 3, and so I get x is 41/3. And that's your answer. I am fine with you leaving it as improper fractions as long as they're reduced. So same thing on number 2, you would square both sides. Let's take a look at number 3. On number 3, the radical is not by itself. This negative 12 is over here, and I need to get that negative 12 to the other side so that I can get the radical by itself. So to do that, I'm going to add 12 to both sides. So I'm going to get the square root of x plus 9 equals negative 7 and 12 is 5. So then to solve, I'm going to square both sides. So on the left, when I square that, I get x plus 9. And on the right, when I square that, I get 25. So now to solve, I'm going to subtract 9 from both sides. And 25 minus 9 would be 16. All right, same thing on number 4. You would subtract 8 from both sides and then square both sides. Number 5 works a little bit differently. On number 5, we got radicals on both sides. Well, as long as it's just one radical, then it's no big deal. We can continue just to square both sides. And on the left, when we square it, we get what's underneath, which is 5x minus 7. And on the right, we get 2x plus 5. So now to solve, I'm going to subtract 2x from both sides. So I get 3x minus 7 equals 5. Then I'm going to add 7 to both sides. So I get 3x equals 12. Divide by 3. So x equals 4. Okay, number 7. Same thing on number 6. We're just going to square both sides. Number 7, I get the radical by itself. Looks like all the other ones, so I'm just going to square both sides. So on the left, I get 3x plus 18, and on the right, I get x squared. Now this one is a little bit different than the other ones because we have an x squared, and when we have an x squared, it means the equation is quadratic. So to solve it, we have to set it equal to 0 and factor. And remember, when we set it equal to 0, we want to keep the x squared positive. So since the x squared is positive where it is, I'm going to subtract 3x from both sides. And I'm going to subtract 18 from both sides. And when I do that, I get 0 equals x squared minus 13x minus 18. Okay, I didn't mean 13. What did I really mean here? I meant 3. All right, now I need to factor it. So I have two numbers that multiply to negative 18 and add to negative 3. Well, those would be negative 6 and positive 3. So when I solve, I get 6 and negative 3. Okay, but here's the catch. When you factor, and for the first few, we didn't need to factor, so it wasn't an issue. But when we factor, there's a chance that you could get an extraneous solution, meaning you could get an answer that wouldn't be true. It looks like it works, but it doesn't quite. So how do we figure that out? Well, we've got to check it. So I'm going to check my answers. So first, I'm going to plug in 6. And I'm going to plug 6 back into my equation, both places I see an x. Now, I'm going to kind of simplify a little bit as I go. 3 times 6 would give me 18. So on this side, it would be 18 plus 18. Over here, it's just an x, so it's just 6. So this would be the square root of 36 equals 6. That is most definitely true. This one works. Let's try x equals negative 3. So when I do that, 3 times negative 3 is negative 9 plus 18. Equals negative 3, so I get square root of 9 equals negative 3. Well, it looks like it might work, but when we're solving, we're focusing on principal square roots, and principal square roots are always positive. This is not positive, so this solution doesn't work. So the technical name for it is that it's extraneous, but we're just going to say it doesn't work, and our answer is just going to be 6. Let's try this again on number 8, so you can see that again. So on number 8, to solve this, I'm going to square both sides, so that gives me negative 4x plus 32 equals x squared. And when I see this x squared, it's going to tell me a couple things. The first thing I realize is that equation is quadratic. So to solve it, I'll have to set it equal to 0 and factor it. It also tells me that I could have a false answer, and then I'm going to have to check my solution. So to solve this equation, first thing to do, I got to add 4x to both sides and subtract 32. And when I do that, I get 0 equals x, whoops, it's a funny looking squared, x squared plus 4x minus 32. All right, so now I want to factor. What two numbers multiply to negative 32 and add to 4? Well, those two numbers would be positive 8 and negative 4. So when I solve, I get negative 8 and positive 4. Since I factored, I'm going to have to check it. So when I go in to check it, I get, first I'm going to check negative 8. So if I plug in negative 8, negative 4 times negative 8, right over here when I plug it in, gives me positive 32. So positive 32 plus positive 32 equals negative 8. Square root of 64 equals negative 8. Looks like it works, but it doesn't, because when we do the principal square root, it has to be positive. So this one is no good. Okay, what about 4? If I check x equals 4, when I plug that in, negative 4 times 4 is negative 16 plus 32 equals 4. So I've got the square root of 16 equals 4, and that is correct. This one is good, so 4 is my only solution. So you might start to be thinking, oh, well, this is easy. I don't have to do all that work. It's always going to be the negative solution that's wrong, and that is not true. It was in this case, but once we do the second set of notes in the second video, you're going to see that negative answers can definitely work. You'll find out that sometimes one answer will work, sometimes both answers will work, and sometimes no answers will work. So yes, you do need to check your answers, and you'll see that more in the second video. Before we finish this video though, there's a skill that we need before we do the next section, and that is to remember how to square binomials. So if I have x plus 3 and this quantity squared, if you write x squared plus 9, this is absolutely positively wrong. That is not the right answer. When you square something, it means to multiply by itself. And this whole binomial is squared, so that means x plus 3 times x plus 3. So now if I'm going to multiply that, I've got to FOIL it out. So this would be x squared plus 3x plus 3x plus 9. So now I combine like terms in the middle, so I get x squared plus 6x plus 9. So look, these things are not the same. This right here is the correct answer. When you multiply or square a binomial, you're going to get a trinomial as an answer. Let's do one more to make sure we're clear on that before we go to the second video. Let's try this one, x minus 5 squared. So when something is squared, we have to write it out twice. And we do that, x times x is x squared. And then we have x times negative 5, which is negative 5x. And then negative 5x. And plus 25. So the correct answer is x squared minus 10x plus 25. And that's what you need to write. And we'll use that skill in our next video.